Right, looking at inequalities here, and it says state the inequality represented on the number line, list the integers satisfied by it. Now, you can probably tell that you're going to get something like this. Now, that's because the dots are at -4 and 1, so hence I've done -4 and 1. And the x in the middle is because the number line is called x. Alright? Now, if you put n, for example, I don't think you'd get marked down, but there you go, just to be aware. Now then, essentially, the line, this bit here, is above -4. So basically, -4 is less than, alright, where my line is. Okay, now it's not coloured in either, and so therefore -4 isn't included. So there you go. Now the other one, alright, the line is beneath or in lower numbers than the 1. So again, we're going to have that, but because it's coloured in, we include it as well. Now the integers, alright, integers, posh maths name for whole numbers essentially, okay, look like this. -1. Don't forget 0 is an integer, right, and you should have that. Now, looking at from the number line, it's all the numbers that are underneath the line and underneath the coloured in. It's all of these, isn't it? So it's underneath the solid bits, basically. Now, for the second part, okay, you know how, if you had to do an equation with these values, you'd be able to do it. And so therefore, all you do is work it out exactly the same. I wouldn't bother changing it to an equals. Okay, I'm going to take 2 away from both sides, and then I'm going to divide by 3. Now, it says represent the answer on the number line, so I'm going to draw a solid dot, okay, because it's equal to as well. And then I want all the numbers that are below 1. So there you go. Alright, so just think carefully. Inequalities are just, whereas equations give you one answer, inequalities give you a range of answers. And so, therefore, that's the only difference. Otherwise, you can treat them exactly like equations.